Hey everybody, I have a problem tonight that I doubt that you'll find in any college or high school algebra textbook. Maybe I'm wrong. We're searching for an integer greater than or equal to 2 that's a solution to this equation, and I call this a non-standard problem because it's non-standard to me. At least you have a function that may not even be a well-defined function here. I'm not sure because you have an input argument and it's raised to a function of that input argument. So who knows if it's really even well-defined? I don't know. But let me know what you think about this. Now notice right here that x equals 1 is a solution, okay? X equals 1 is a trivial solution. If you put 1 right here, it's clear, isn't it? It's just 1 raised to the 2, which is 1. And then over here it's going to be 1, right? So that's why I went for this, so it'd make it a little bit more of a challenge for us, all right? So we're looking for an integer x that's greater than or equal to 2. That's what this symbol stands for. Now what we're going to do is just take advantage of, this particular problem is a triumph of rational exponents. And I'll just write it down underneath. I'm sure a lot of you are familiar with how to write this as a rational exponent. You can write this as x raised to the x plus 1 over 7. Again, it looks a little strange to have x in more than one place on something like this. That's what I first thought when I composed the problem, but it seems to work okay as far as just equations. Again, as far as whether it's a well-defined function, that's a whole other question. So this is equal to this, all right? Now right here we have on the right-hand side, we have x raised to the 12th power, something concrete for once, times x raised to the 2 sevenths, 2 over 7. Now you'll note right here that this is a standard sort of situation where you have the same base, so you can add your exponents. So this is equal to x to the 12th plus 2 over 7. Y'all, 7 times 12 is 84. 84 plus 2 is 86. And so right here we will get x to the 86 over 7. Again, a rational exponent here makes this a lot more manageable. That's why a lot of people prefer fractional exponents. Okay, and again, y'all note that 7 times 12 is 84, right? Okay. Okay, so now another property of an exponential is that it's a one-to-one, they call it a one-to-one function. And so we can equate the exponents right here. On the left-hand side, we have this exponent x plus 1 over 7. So we have x plus 1 over 7. We can equate that to the exponent we got on the right-hand side. This is an equality. All right, so we have 86 over 7 here. See, and it just melts in our mouth at this point. By inspection, we see that x has to equal to 85. So I thought it was a fun problem. And again, let me know if they're putting these kind of questions in college textbooks. It's been a while since I taught or have done math in college. But these kind of problems were not a common type of problem in the algebra, middle school, or college algebra textbooks. So anyway, I got x equals 85 right here. We've solved the problem. And there's a corresponding logarithm question you can ask. Anytime you have an exponential statement, you have a corresponding logarithmic statement. So I think this is a different class of problems. So let me know if you've seen this before. I got x equals 85. So that's all for tonight.